Good afternoon, everybody. My name is Rudy Shankar. I'm the director of the Energy Systems Engineering program at Lehigh University. And welcome to our ESE seminar series. This is the 8th one this fall semester, and it's the last one. And by any stretch of imagination, this is probably one of the more important topics you hear, the growing demand for nuclear energy. And to present this is Tina Taylor, who's no doubt one of the experts in this field. Tina has given this presentation to previous cohorts of students for ESE, and thank you much, Tina. Tina is a Deputy Chief Nuclear Officer and Senior Director, R&D, at the Electric Power Research Institute. She's responsible for a diverse portfolio of research addressing the most technically challenging issues facing nuclear power. Her team is responsible for work in the areas of maintenance, engineering, equipment reliability, instrumentation and control, risk and safety management, chemistry, fuel, high and low level waste, and decommissioning. Additionally, Tina leads the EPRI's effort related to training and technology transfer. Has worked in the electric power industry for more than 30 years and joined EPRI in 1997. At EPRI, she has worked in a breadth of areas, including nuclear power, environment, sustainability, renewables, and engineering services. Prior to joining EPRI, Tina specialized in chemistry and corrosion in nuclear plants, working as a senior engineer at B&W Nuclear Technologies, and before that as an engineer at Northeast Utilities. Tina holds a Bachelor of Science degree in Chemical Engineering from Tufts University. Welcome, Tina, and the floor is yours.
All right. Thank you, Rudy, and I appreciate you inviting me back to speak again this year. I love to talk about nuclear, so it's a joy for me to do this. I have put together quite a collection of information really aimed at trying to help everyone understand the current state of the nuclear industry and what's ahead. I've decided what to talk about based on what's interesting to me, and I hope that'll be interesting to you all. But please feel free to type your thoughts in the chat, ask questions as we go, because I do want to address whatever's on your mind about nuclear, not just talk about solely what's interesting to me. I put the word rapidly into my title, I think, since we settled on what my talk would be earlier this year, because things are changing in this space. It feels like daily, but definitely at least weekly. There's new announcements, there's new challenges, there's positive news and negative news going on. So I've tried to capture a lot of that in what I'll talk about today. I'm going to start off with just giving you a little grounding of what the nuclear industry looks like today. This might be old information for some of you, but I think many of you might not be very familiar with this. And it's good to understand the magnitude of the current size of the industry as I talk about what some of the projections are, so you can get a real sense of I might even say how little of a contributor nuclear is today and how big of an opportunity there is for nuclear to play a role in the future. And that contrast between what has been happening in nuclear and what's being called for ahead, it creates some of the opportunities and creates some of the challenges as well. So this slide shows kind of the breakdown of nuclear plants around the world. There's 437 right now operating in 32 countries. Most of those plants are in the US, but I will tell you that China is rapidly growing their fleet and will pass the US and France at some point in the coming years. France has the highest percentage of nuclear, I believe. That's still true in the world, with 56 plants right now, and they have plans to expand. And you can see some of the countries have just a few plants. And you don't have to memorize any of this, but I do want you to sort of keep in mind, I think the one real takeaway from this whole discussion is the scale of nuclear. So 437 might sound like a lot of plants, but it's actually not a lot of plants when you look at all of the renewable and coal and gas generation. It's only about 10% of the world's energy production. And this really electricity is from nuclear. In the US, that's a little higher. It's about 19 or 20% of the electricity is nuclear. There are a lot of plants under construction and a lot of plants being planned. And so for contrast here, I show at the top what the situation looked like 2 years ago. In December of 2021, we had 56 plants under construction at that point. A few of those have come online. But I looked up the information this week, and now there are 60 plants under construction. So some new ones have been started. That activity is spanning across 17 countries. Beyond what's actually in construction right now, there's 110 additional reactors that are planned and over 300 more that are proposed. So just that planned and proposed reactors would double the amount of plants that are currently online. And another thing that's important here is that it's spreading to many more countries around the world. So I showed you that there are 32 countries that currently have nuclear. There's an additional 30 countries considering or planning or starting new nuclear programs to get ready to adopt nuclear into their countries. And that's a big undertaking because when a country embarks in nuclear, there's a huge real infrastructure need to support that program. So there's regulators, there needs to be a regulatory, usually law or governance set up. That all needs to be staffed with knowledgeable people. In general, university programs will start up to produce the future people that will design and work at these plants. There's an entire supply chain needed to build the plants. There's a different and overlapping supply chain needed to support the ongoing maintenance and updating of the plants as they go. So each time a new country kind of comes into the fold, it's a very large investment in the infrastructure, if you will, like the people side of things, especially, and capabilities. So that's kind of current state and what's on the books right now. I want to give you a feel for the change that's been going on over time. So this shows plants that were added to the global fleet, kind of above the zero line, and plants that were shut down below the zero line over time. And you can see in the 70s and the 80s was when the bulk of the existing plants were built. And something to take away here is in the last 30 years, really, the new build of plants has been relatively modest every year. Maybe 2 to 10 plants coming online a year. We did have periods of high production in the 80s, and we'll need to be exceeding what we've ever done before going forward. And I'll paint a picture of what that demand looks like. You also see on here a few points in time where things changed dramatically or caused a pause. So the 3 nuclear accidents that I'm sure come to mind if somebody starts to express concern about nuclear: 3 Mile Island incident in the US, the Chernobyl incident in now Ukraine, was the USSR, and then the Fukushima incident that happened in 2011. Each of those has shaped really what has happened going forward, and generally caused a slowdown or a dampening of appetite for nuclear, and then it's picked back up again in the future. So I want to help you to understand how and why things slowed down for quite a while, and that has an impact on where we're going in the future. So I mentioned most of our build happened in the 70s and 80s, was slowed down a bit after 3 Mile Island. There weren't as many new starts. And after Chernobyl, some plants that were even planned or underway were canceled. So there was a slowdown in the growth of the fleet. And then in the earlier part of this century, there was really a real slowdown for nuclear, where plants that were already built were shutting down, and kind of two reasons for that. One, as I mentioned, the Fukushima accident caused some countries to change their policies on nuclear. So a real example of this is Germany. They decided to shut down their entire fleet of nuclear after the Fukushima accident. And then in Japan, new requirements were put in place to shore up their plants from impacts from tsunamis, which was the cause of the Fukushima accident, and from earthquakes. And that has required many plants to build large amounts of infrastructure for the Japanese plants that will allow them to restart. And right now, I think it's about 10 plants have restarted and another 9 to go. Not positive on those numbers, but that had caused a slowdown.
No call.
In the US, we saw something completely different happening. We saw downward pressure on nuclear plants from the marketplace. So there were a lot of wind and solar being built. A lot of wind and solar had production tax credits, and that really suppressed the cost or the value, the money that plants got paid for producing electricity in the US, even to the point where at many times in areas of high wind, particularly at many times, especially at night, the price of electricity went negative, meaning a nuclear plant had to pay the grid operator to keep operating rather than getting paid for the electricity they were putting on the grid. And that happened because, for example, a wind generator receiving a production tax credit could actually sell their electricity for $0 to the grid, but make money because they were getting credits for that. And so that cost pressure on US plants kind of combined with increasing O&M costs, some of that driven by additional requirements that were put in place following Fukushima, got us to a point in the 2010s where many plants were facing a shutdown. And in fact, several plants did shut down during this time in the US. And another batch of plants was near shutdown and then was kind of saved as the sentiment started to swing. And then going into 2020, we started to see this renewed opportunities for nuclear. And some of the drivers I'm sure you hear about every day these days, there continues to be an increasing focus on climate change and carbon-free electricity, huge needs to decarbonize not just electricity, not even just energy, but like the whole economy. Continual issues that make us all aware of the need for robust and resilient energy systems. We've had storms, we've had power outages in different parts of the world. There's continual rolling constraints on need for more and more energy. As we start to see the initial phases of electrification, that's causing more demand. I'll talk a bit more with some examples on industrial applications for nuclear. There's this whole growing industry around future low carbon energy carriers that will create a large demand for hydrogen, maybe ammonia, that could be produced by nuclear. And then, this changes over the last few years. We see a lot going on in geopolitics that really impacts the energy sector. So things like the war in Ukraine, for example, has caused impact to the energy sector all around Europe for many reasons. The energy flows have changed. There's been constraints on gas flow to different countries that triggers changes in the cost of electricity. It really has changed like the flow between countries across Europe. And then, even the politics of that with Russia and China being very predominant in the nuclear space, projects that were planned, projects that were canceled, countries taking different stances on what technologies they want to use and what countries they want to partner with for their energy supply chain. All of this has really produced more opportunity for nuclear as people want to have robust, secure, resilient energy systems going forward. And this was kind of where we were last year when I spoke with this group. I don't know how many of you were here last year or if it's all new people, but last year I would kind of express where things were as optimism. There was a growing need for nuclear. Some of the obstacles were being broken down. Things look pretty good, and it's changed a lot over the last year, and I'll try to give you a sense of that. So I think as the shift was starting over the last few years, one of the things that's been important is having a lot of thought leaders weigh in on nuclear. So politicians, public figures, people we turn to, all started to coalesce around nuclear being a really important part of our energy future, and for different reasons. And you can see some of that here, but a lot of environmentalists have really embraced nuclear as they understand the positive attributes that brings to a carbon-free system of the future. People who were previously against nuclear have turned to be for nuclear, especially as they think about new nuclear designs that are available in the future. And this has started to really, I think, lay the groundwork really across the public and policymaking for people to be very, to think critically about what are the concerns about nuclear, what are the opportunities for nuclear, and be very open-minded to evaluating that on kind of a neutral playing field, if you will, not coming immediately to a conversation with a anti-nuclear shade across things, because that's what you had always heard. So this really, I think, started to change the discussion and the tenor of the discussion kind of on that national and global level. And these and many other thought leaders helped really shift the conversation for people to, I think, just really consider what makes sense factually. But what we've seen over the last year has really surprised me. So I kind of am characterizing this as over the last year, nuclear has gone viral. So what I mean by that is the discourse and the appetite for nuclear is now really penetrating into the everyday. So one of the coolest things, two really cool things I highlight here that resonated for me. I don't know if you've had an opportunity to hear our current Miss America speak. She's a young woman from the University of Wisconsin, Grace Stanke. She's worked at Constellation Nuclear as an intern. She's a nuclear engineering student. And she has decided to use her Miss America platform to spread the word about nuclear and the opportunity nuclear presents for us to solve some of our major societal challenges going forward, and also to help young people, and particularly young women, understand the value that can come from them participating in this as they think about what their careers will be in the future. And so she's just been brilliant, I think, going around the world and speaking to young people from a science-based position about her passion around nuclear energy. And I honestly never thought I would see that day where Miss America would be a nuclear engineering student. So that was pretty exciting to me. And as a woman in this field, it hasn't always been the case that women were encouraged to go into, science in general, but nuclear in particular. The other cool thing that happened for me this year that I take as a signpost that nuclear is going mainstream is there was an Oliver Stone film released this year called Nuclear Now. And it was in the theaters, and I got to actually go sit in a real theater with a big gigantic screen and my popcorn and soda, and watch a really good documentary around nuclear. And if you have more interest in this topic, I think this would be a great place for you to go. I think it's available now for free on streaming services. It was out in theaters this summer and kind of made the rounds around the country. But I think it's really well done, and it presents a lot of information around the history of nuclear, where things are at now, the concerns people have, what's going on in different countries, the activities that are going on in new designs and new opportunities. And it's probably a wonderful cinematography experience of a lot of the same themes that I'm talking about today. So the fact that people could go to their local movie theater and really learn about this in a enjoyable way was, I thought, just wonderful to experience this year. I'm curious if anyone else has seen it. Maybe put a note in the chat if you got a chance to see it this year. And then this goes, I think, beyond me and my generation. We now have nuclear influencers, another thing I couldn't ever have wrapped my head around. I've highlighted 3 of them here. I don't really live myself in the TikTok space, but it's interesting to me to understand that that many other people do, and how do you get good information about these highly scientific topics out into the general discussion. So if you are a person who follows TikTok or lives on Twitter and you want to know more about any of these things, these are 3 good people I've found to follow. So the first one I wanted to highlight is her handle. I think that's what you call it. I don't know what you call your nickname. Is Miss Nuclear Energy, and she's a student from MIT with a PhD, working on her PhD. And she does a series of TikTok videos, and I think all 3 of these women really have this in common. They're trying to get factual information out there and answer people's questions and concerns, but do it in a way that is digestible for people on 30-second increments or short tweets or X's, whatever they're called now. And I think this has got to be really valuable around the world for reaching the next generation with good information, not just fear-based or hype information. So there's another woman who's a model from Brazil, called Isodope, and I've seen some of her videos. She is maybe I might characterize her as like the Lady Gaga of nuclear industry. She has a lot of interesting outfits and costumes and visual stuff going on in her videos. And then another woman also that I highlighted who's more active on Twitter, called Nuclear Hazelnut. And this is Jennifer from Westinghouse. She's currently working in the industry as a nuclear risk analyst. And I think it's amazing that these people have really dedicated, a lot of their time probably to try and be a voice to spread good factual information in a way that's digestible and memorable for people. like I say, that's all a little bit new for me, but I think I can see where it's valuable, and it's really helping to create this and many other avenues, really helping to create a groundswell of support for nuclear with a new generation of people that can, look at what the challenges are for the next century and understand and make decisions about where do different technologies fit into those challenges. So it's been a pretty exciting year for me to see something that I've worked on and nobody ever cared about at cocktail parties go not just to it's an interesting topic at a cocktail party, but my 11-year-old niece can watch these TikTok videos and get educated. So in the face of all this, I'm kind of characterizing things as skyrocketing at this point. Huge need for clean energy in general, and nuclear is kind of a big part of that discussion. Highlighting just what this looks like. It's changing very rapidly. So I think it's almost 2 years ago now, there was a survey done in the US looking at existing utility members, existing utilities who have existing nuclear, and asking them, do they see if they plan to build more nuclear? And just within that community, which is a very small subset of the utilities in the US, I think it's about 23 utilities have nuclear plants, and there's like 1,100 utilities in the US. But just within that group, when they aggregated the responses from that survey, there was over 300 SMRs planned. When you look globally, IEA had projected doubling the amount of nuclear between 2020 and 2050 to meet net zero in the electric industry. And when you expand beyond just the electric uses and look into industrial uses, NEA, the Nuclear Energy Agency arm of OECD, projected tripling by 2050 for the world to meet net zero. And that's just a huge challenge. It's an opportunity, but it's a challenge as well. When we look over the last year, there has been even more acceleration of this change that I want to try and help you get an appreciation for. So these are US numbers. And one of the things we're seeing in the US is a rapid onshoring, if you will, or reindustrialization. A lot of this has been driven by government policies like the Inflation Reduction Act that are encouraging this. Some of it is driven by the understanding of supply chain issues, when we're getting our energy supply chain heavily intertwined with geopolitics in some cases, and the desire to have our own security. And other parts of this are driven by the simultaneous desire for all of these industries to become net zero and have their own energy security. So the two charts I want you to look at here on the top of the page on the left, it's the annual electricity consumption up to 2020. And you can see that while it grew a lot between 2050 and say 2000, over the last 20 years, it's been relatively flat in industrial, very flat in industrial growth, residential and commercial, and hardly anything in transportation. On the right-hand side is looking forward. And you can see all of these projections rapidly increase between 2025 and 2050. And as that timeline gets shorter, as we make less progress in decarbonization and less progress in margin of electricity we have available, that slope just gets steeper to meet this demand. And some of these needs are huge. even, putting one new battery plant or one new semiconductor plant online can take the equivalent of some of these small modular reactors just to power that one plant. And this is changing so rapidly, I don't even really know how to articulate how rapidly it is. But one example that I read last week that just kind of blew my mind is what I have here from Georgia Power. So every year, it used to be, I would say, less than once a year, utilities and really like on a state level, they're required to look ahead for integrated resource planning and discuss that with the public utilities commissions and state legislatures, depending on how things are run in a state by state. People are always needing to project their future demand, to have a plan for how they're going to meet that, to go through this iterative process to get rates approved, to support those capital investments, to meet those plans. And you can imagine in the last 20 years, that's been relatively stagnant, easy to do, right? People were shutting down coal plants, replacing that with gas plants. There was this huge build out of renewables that was, helping to meet the slow growth of the demand in the US. This example from Georgia Power, I think, is mind-blowing. So in 2022, just a year ago, or maybe a year and a half ago, their integrated resource plan looking ahead to 2030, so just an 8-year window, was that they would have to add 400 megawatts. And that was bigger than anything they had been doing for the last 20 years already. Their projection from a month ago, again, for 2030, now just 7 years away, is that they'll need to add 6,600 megawatts to meet the projected demand. That's an increase of 1,600%. So how companies can make this happen is a huge challenge, but a real one, because on the other side of that, there's other companies planning to build these plants, these factories, to build more things that will rely on electricity, like electric vehicles. And this huge demand is not going to go away, and it will need to be satisfied. And it'll likely need to be satisfied with low or zero carbon energy sources, of which nuclear is a great match. Alongside this kind of growing demand, we are seeing many new commitments to nuclear, many new announcements. I've just kind of screenshotted a few of them here. It's going on around the world. I mentioned China already is on a big trajectory to build a lot of nuclear, and they're well underway in their progress of doing that. But many plants that have not had an eye towards new nuclear, many countries, I mean, that have not had an eye towards new nuclear, are making announcements, and these are coming up, like I said earlier, like daily or weekly. So I just wanted to hit on a few of those here. France, I mentioned, has one of the biggest nuclear fleets in the world. Their growth had been, they completed a large build. They had some new designs. They had, I think, one plant under construction. They're now going even more all in on nuclear. They announced this summer plan to build 6 new large plants. It's a $52 billion program that they're investing in there, and they know they're going to need more beyond those 6. Sweden had actually been in that phase where they were shutting down some of their plants. They shut down a couple of the older plants and didn't foresee a growth in electricity that was going to need them to build more plants. But just in the last couple of months, they've really shifted their plans going forward. And now they're planning a, quote, massive expansion of nuclear energy. Poland has been working on nuclear plans for the last couple of years. They're looking at large nuclear plants. They're looking at nuclear for industrial use. So there's many industrial customers there that have some MOUs in place for building SMRs, small modular reactors, to go along there. They're rapidly ramping up their infrastructure development in the country with nuclear regulator and university programs and supply chain. And they actually hope to be a center for a lot of the nuclear support for the rest of Europe. And they previously had no nuclear there. In Canada, they have aggressive and growing plans for new nuclear there as well. Canada is a nuclear country. They've historically had CANDU reactors, which are large reactors that were designed in Canada and built in Canada and built in a few places around the world. They now have a very active small modular reactor program going on there, and they may end up being the place that the first light water small modular reactor gets built. And this is really going on all around the world. I mentioned there's 30, we call them newcomer countries, planning to enter nuclear in the future, and all of them have various stages of announcements going on. What I expect you'll see in the news next week or the week after is a big commitment by several countries coming together, led by the US, to make a pledge at the upcoming COP meeting. That's the Conference of Parties, kind of the annual gathering where countries get together to try to determine how they're going to tackle climate change. And countries typically make commitments. There hasn't been a great track record of being able to meet those commitments. If you think about some of the past meetings of this are things like Kyoto and the Paris Accord. The next one's in UAE next week. And this is aligned with what I showed in some of the prognostications from nuclear industry organizations, where I said that IEA had suggested a need to double, and NEA suggested a need to triple. This is now coming from the governments, and the governments are very, very important to support the sustained investment and the favorable business climate and the important regulatory regimes that are needed to actually bring these plants to fruition. So I see this as a very big turning point for the nuclear industry, because now it's not just developers trying to say what they think nuclear can do for the future, and it's not just the nuclear community itself, which of course people in the existing industry think very favorably of nuclear and want to see that be an important part of the future. But this global government support, I think, will be a very important aspect and maybe turning point going forward. I see a couple of questions, so let me just take a look at those. I'm glad somebody saw the documentary. That was good. I don't have actually any data in this presentation around hydrogen and how much nuclear will be needed for that. But I might be able to get some of that information and pass it along. So this question about what is the role of federal government in de-risking the investment from the private sector is a good one maybe to touch on while I'm on this slide. So there's actually quite a lot going on. I'll talk about the US first, maybe. There's quite a lot that has been going on in the government space to try and do this, to de-risk things, to accelerate some of the initial development. One of the interesting things that might not be obvious, that's been interesting to me, is really the investment the government makes even in the university system. So going back probably a decade, at least in the nuclear part of Department of Energy, and I don't know exactly what drove this. I assume it was some congressional policies, but it could have just been a great leader at DOE. There was a commitment made to use about 20% of the DOE's R&D money to fund work at universities. And that has, I will say, that has made all the difference in where the nuclear industry sits today, because a large number of students went through those programs that were essentially funded or, helped funded by the US government. And that produced this whole crop of smart, educated, young nuclear entrepreneurs that were kind of, entering this industry at a time where the need for a climate change solution was really front and center. And when I talk a little bit about some of the companies that are engaged in that, I'll highlight how many of these new designs and new energy around advanced nuclear really came from that investment. But then there's been a lot of other places the US government has been investing in nuclear. So, and this goes back, I'm not quite sure, maybe a dozen years. There have been support for many of the new reactor designs in initial design space, in interface with the regulator, in unleashing the power and capabilities at the national labs to support these companies. The recent, there's loan guarantees available, and the Vogel unit, that was the most recent unit to come online in the US, was supported by a DOE loan guarantee, I believe. There's 2 advanced reactor demonstration projects being highly funded or cost shared by the government. And that should help get some of those projects across the finish line. But a spoiler alert, one of the projects that the government has been trying to help was recently canceled. And I'll talk about that in another slide. And I'll also address the comments there on the NuScale project. I have a discussion of that coming up. And so you're already, I think, getting the sense that it's not all rosy, right? There's opportunity here and there's challenges, but not everything is going super well. So as I go into the future, I want to just hit again on this aspect of scale and what we've done before and what we need to do in the future. So nuclear energy in the US, there was an initial successful test in Idaho, I believe, in 1951. And then just 7 years later, we had our first commercial plant. That's not going to happen these days. Things do not move that fast anymore. And then from 1958 to 1990, we built over 400 reactors around the world. So a very rapid increase happened during that period of time. But that was 30 years to build 400 reactors. And if you think about what we've talked about so far, this idea of tripling from now to 2025 is a much greater challenge than that. And we have been operating under this flat, very slow growth mode for such a long time that really shapes the industry we have today. In the US, there is now completing this one build of one plant, 2-unit plant, Vogel. Over the last 20 years, that's been kind of the sum total of nuclear construction in our country for the last 10 years. Those plants are now finishing, and there is not another plant being built tomorrow for that workforce to go just migrate to, even if that was feasible. So just try to have an appreciation for the fact that the slowdown, the stagnant, the relatively modest growth that we've been under really shapes what the capabilities are to go on this rapid expansion. And I think that we will see a lot of reality seep in to some of these ambitions as we try to kind of bridge that gap between a slowly growing, stagnant industry and one that needs to scale very quickly. Kind of keeping on this theme of the amount of nuclear that's needed to be built. This chart, I think, probably has the same information as before. but you can see that the kind of peak year for putting new nuclear on the grid was in the mid-80s, where we put just over 30, equivalent to 30 large plants on the grid. And if we're going to meet these goals going forward, we know we can't go from 0 or 5 or 6 per year now to 30 immediately, but we will need like the entire infrastructure to be able to build these plants to grow very rapidly, to get to any of these targets by 2050. And we'll need to be doing every year from, almost the immediate future to 2050, as much nuclear build as we have ever done around the world before. And I would say we have not been on a trajectory to ramp up to that point. So it'll create some of the challenges. We'll see. Most of what I've talked about so far is really aimed around electric production, but I want you to also know that industrial momentum is underway here. So, most, if not almost all of the nuclear today, the plants create electricity. That electricity goes on the grid and it gets used for a variety of things. As we're moving forward, there's this desire and need maybe for many industries to be more directly coupled with nuclear. And there's some advantages to that, and there's some challenges to that. A big wave is coming in the IT and data space, because that industry itself is so rapidly growing. The I don't know what you want to call it, revolution this summer over AI and ChatGPT and things like that is I guess exponentially probably increasing the need for data centers around the world. And those data centers and the companies that run them are under this same desire and constraint and regulation to become carbon free. So there's been a lot of work going on this summer, particularly around coupling nuclear with data centers directly. So a few announcements here. NuScale just announced a partnership with Standard Power to build 24 small modular reactors to power their data centers. In Virginia, there was a green hydrogen hub envisioned and moving forward that'll include SMRs as their power, and it'll include hydrogen generation, it'll include data centers. And then Microsoft generated all kinds of press last month or in September just by posting a job opening for a nuclear person, because in their job description, they said this person would help develop and implement Microsoft's plan to power their data centers with nuclear. So there's this whole new demand developing that's kind of on top of everything I talked about for the need and the opportunities here. So a crystal ball question here, I like that. For what states are most likely to be first to get an SMR? I think I'm going to go with Tennessee on that one. So TVA, last month I would have said Idaho, but this month I'm going to say Tennessee. So TVA has a site, the Clinch River site. They have an early site permit procured for that. It's a good place to build one of the first plants. It's closely coupled with Oak Ridge National Lab. TVA and Oak Ridge both have tremendous capabilities in the nuclear space. There's very good state support for nuclear there. The governor is very interested in this project. There's DOE support for that project. They are also working with Canada and with GE to kind of all work together on these initial small modular reactor builds. I think there's a very good chance that'll be probably the first one to come about. And then moon power. I'm going to kind of end with that one, but let's keep that in the back pocket for now. But that's going to increase the activity in this space even more. All right. At the same time, there's this just desire to grow and this need for clean energy. There's also like real problems going on in grids around the world around adequacy, around the type of generation and the type of demand curves. And I just am highlighting two things here. I think you might have heard from my colleague, Mike Caravaccio, about situations in ERCOT. I know there was an event a few years ago where there wasn't enough power to keep the lights on. And I think during August this year, I want to say all summer, there was intense concern about if they were going to have a power outage because of not having enough electricity there. So that's, right in our own country where we totally take for granted that we can turn on the light switch and there'll be electricity. And if it's out for some reason, it'll come back on as soon as, somebody replaces a transformer. In South Africa, by contrast, they've been living in an underpowered situation for decades. I was there in, I think, 2010 and had rolling brownouts going on then. They've had relative periods of being able to meet their energy needs. But this last year, they've been very constrained with almost constant load shedding with just basic, supply demand. Their demand is higher than their supply. Both of these places have nuclear plants, and nuclear plants have been kind of on that critical edge of keeping the lights on or contributing to that shortage when they're not available. And this, I think, is even a bigger driver in some of these newcomer countries that are looking at nuclear. I think I'll just mention this one in passing, but there's also increasing work going on at looking at what can be done behind the meter. So more closely coupling direct use of energy, whether that's electricity or electricity and heat, kind of to things that happen within, say, the boundary of a plant or a closely coupled boundary of the plant. And there's a lot of good drivers for this. If you can use the heat itself from the nuclear plant in various processes like hydrogen generation or in industry, you can get even more efficiency out of the combined system. There's also financial aspects of that. And that's what's driving some of the data center coupling. And this is very different state to state and what the paradigm is and how energy is costed when it goes on the grid versus how it's lower cost kind of behind the meter. But that's maybe a more esoteric discussion. So we kind of arrive at this point now where we have I'll say, healthy global nuclear industry. It's only providing about 10% of the world's electricity. It's relatively stable. There's this huge demand out there. Can nuclear meet this challenge? And truthfully, I don't know. Like I think of myself maybe a lot like this little boy here. It's like full of optimism. There's this big world out there. Maybe the nuclear industry has this jetpack on its back and is ready to go. But truthfully, maybe it's really only made out of cardboard and he's not going to fly too far. So I want to give you a sense of what some of those challenges and realities are, because I think this is kind of the key thing, right, about our whole energy future is everything's hard and everything's intertwined. There are many different designs out there. I'm not going to try and get you to understand all of these. Most of these designs, I will say, have been really fueled by this investment, I believe, in the university system and in educating more young people who are then entering the workforce with entrepreneurial spirit, with a desire to save the world with clean energy, and a knowledge about nuclear and questioning, like, how can we do nuclear better than we've ever done it before? So lots of new designs, lots of new companies emerging, lots of innovation in the technology space. There's even innovation in the business model. So one of the companies that's out there that I find very interesting is Last Energy. They have a design that's not really very new. It's a scaled down traditional kind of reactor. But they have been able to procure power purchase agreements over for $18.9 billion of worth. And they're not doing it by selling people nuclear plants. They're doing it by selling people the electricity and the energy from nuclear plants. And by really focusing on what they believe is a very easy to license and easy to construct small modular approach to providing that energy. So I'm very interested to kind of keep my eye on them. They're doing something very novel out there, but not so much on the technology side, on the business side. But here's kind of the reality of where things are right now. This is actually a slide I used with you guys last year to talk about the new things that were underway. And some of it's positive and some of it's really slowed down. So TerraPower is planning to build a plant in Wyoming. That project is delayed just by a couple years, I think, at this point, but it's been delayed. Just last week, there was an announcement of this, I don't know what to call it. It was kind of like the poster child for a good nuclear project. NuScale had been working with a utility called UAMPS in Utah to plan this carbon-free power project. This is the project that was highly supported by DOE to help with licensing and permits and design finalization. And last week it was canceled. NuScale, I think, still will go on with many other irons in the fire, but it's really kind of heartbreaking to see this project come to a halt. It's been underway for, I think, a dozen years, and I thought would be the first small modular reactor built. And, a couple things are going on there that really are probably defining the challenges. At the end of the day, the cost to procure this electricity by the co-op of utilities that would use it crept up and up to the point where it was not economically the right thing for those utilities. I don't know if there's more the government should have or could have done here. I don't know a lot of the details in the agreement between NuScale and UAMPS as to what actually drove that to become untenable. But it's not going to be cheap or easy to build any of these first of a kinds. And I think that's a reality check. The X Energy plant, which was originally going to be also in Idaho or the Northwest and provide electricity. The demonstration actually switched over the last year as X Energy formed a partnership with Dow. So the demonstration plant supported by the U.S. government or helped by the U.S. government is now going to be industrial use of that energy. A couple of the other things that I had talked about last year, the Kairos project continues to move forward. They have recently submitted the construction permit for actually their plant number 2, which will be producing electricity to the grid. They've continued on the TRISO plant. So kind of some mixed news in reality. I'll just mention most of the new build experience really has been with Russia and China, and that creates more of this challenge as many countries around the world are seeking to add new nuclear. And there's geopolitical tensions that dictate who will and who won't work with Russia, who will and who won't work with China to try and move their projects forward. construction times on all these plants have been a huge issue. So when you think about, we're talking about building all these plants between 2030 and 2050. And when you look in this on this chart, you see many of the construction times exceeding 15, 20 years. This is a big challenge. Many people are working on how do we do this faster? How do we do it more reliably? I realize I'm running out of time here, so I want to hit a couple more points and then have plenty of time for discussion. The need for cost certainty is huge. And that definitely contributed to the the carbon-free power project I just talked about, because over the years, the estimate for what that cost would be for the electricity increased. And the cost, I think, could be high, medium, or low for nuclear to still play an important role in future energy decisions, but the cost can't be uncertain if businesses are involved. If it's government programs, which is what it is, how it works in many countries around the world, then there's a bigger ability to bear that changing cost structure. But for businesses, they need cost certainty, they need schedule certainty to plan these. So those are some of the concerns and considerations. Supply chain concerns are growing. They're growing rapidly. Maybe they definitely started in the nuclear space with the build of the Vogtle and the VC Summer plant, where VC Summer plant was canceled. The lack of a robust supply chain impacted those plants on schedule, impacted those plants on costs. I think we all became very familiar with supply chain impacts as we went through COVID and couldn't get toilet paper sometimes and couldn't get meat sometimes, and other times you couldn't get chicken. And we've been really living with that for the last 3 or 4 years, I think, as prices fluctuate quite a bit for the things we need to buy, and there's difficulty getting things at different points in time. It really heightens your awareness. And this is probably the biggest discussion underpinning that reality check on all of the nuclear growth discussions that I mentioned. There's a lot of realization that a lot of work needs to be done to build the supply chain to support any of those nuclear ambitions. And this is all kinds of things. This is the large specialized components. It's companies that can perform work to a nuclear quality. Workforce is a huge gap people see, both from the need to have highly educated, specialized workforce, and also just the trades, the people that will weld these plants together and pour the concrete. Big gaps to be challenged there. There's challenges in fuel. Some of this is driven by geopolitics, particularly with the Russia-Ukraine situation a couple of years ago. That introduced a big shakeup in the uranium supply chain around the world, and that has led to a steep increase in the cost of uranium, which then kind of circles back and increased the cost of the production, the projected cost of electricity from these plants. The US government and other governments have been ramping up activities to create more production, but that's really probably only sufficient for the current fleet and moderate growth. As we start to encompass these very large builds, we're going to have to address this as a critical part. Regulation is very important from the timeline of things. I'll just say that many countries are just standing up their regulatory paradigm. And the current idea of licensing every single plant individually will either create a huge slowdown, it'll create a need for gigantic staff at the regulator, or we've got to do it differently to support a very rapid succession of approvals and proper oversight for a rapidly growing fleet. So I hope that that's given you a good feel for kind of the positive and some of the challenges. I think that personally, I think the future is full of opportunity. But there are these challenges that'll need to be overcome to actually unleash that opportunity for nuclear. So let me just check the chat for a few questions, and I'm happy to take questions verbally as well. I will come back to some discussion on space and fusion if there's time after questions. And then there's a question here about co-locating generation and the load. There are challenges there, and there's really just the beginning of some real demonstration there. So I think on one of my earlier slides, I had the constellation hydrogen pilot going on. That's maybe one of the first ones I can think of where there's been actual, you can think of it like industrial infrastructure, but in reality, it's not that huge. The hydrogen production at that plant being put, inside the boundary of the plant. That is only taking electricity. It's not taking steam from the plant. Those will be more challenges to overcome, but there is a real efficiency driver if we can do that. This idea of kind of paying the fair share of the electric infrastructure cost, I think, is a real one. I think there are drivers that exist for different people, different places right now for things to happen behind the meter. That really is driven by the current regulatory pricing approach in various areas. But certainly if everybody started doing everything behind the meter and then all of the costs of maintaining transmission was being borne by residential users, this could be an issue. And I think the industry's already grappled with this a bit as people have, as there have been large build outs in some areas of the country with personally owned solar. It's kind of the same issue there. If the cost of maintaining the whole infrastructure is embedded in the electric rate and part of the economy is not participating in that part of the structure, there might need to be rate structure changes to support that. And then electrical grid improvements is a big one. And I think that really underlies the whole ability or challenge to the energy system growth and transformation. And that comes back to a lot of the same drivers, the workforce, the supply chain, the investment appetite, the forward planning is a big one. But it's quite possible in the US and in many other areas, the grid ability to support a nuclear build out could slow things down. And then what are the opportunities to think about education as the IRA is implemented? There's definitely opportunities in the university space, both to invest in the infrastructure that universities themselves have and to expand the programs of education so more people can go through that and be educated. And another thing that's overlaying that right now is, which is very interesting to me, is the concept of equity and environmental justice, which is kind of, I think, helping the country and the world to think about reaching further. Let's make the opportunity ubiquitous for everybody. Let's figure out how we can use some of the advances in education technologies themselves and this desire for universities to play a role in the energy transition itself. I think that spreads more money to more universities, which can help more people get engaged in not just the work, but in the effort to grow the workforce at the same time. All right, so what other discussion would you like to have, or what questions do you have?
Great. You promised, Dina, that there's a lot of exciting things going on, and you alluded to that. Went into great detail. But I want to give the students in the audience the first chance to ask questions of Tina. So you can ask this through audio. Please unmute yourself and introduce yourself and ask a question, please. And then when asked all the student questions, we'll go to the general audience. All right, students, questions for Tina.
I see Elizabeth has
Yeah.
her hand raised.
Hi, I'm Elizabeth LaRue. I'm a computer engineering undergraduate. I was wondering how the placement of these plants affects how much power is actually being able to be put into the grid, and if they have to be more spread out, or if some of them can be close together.
Yeah, that's a really good question. And it's dependent on the grid and where the demand is and kind of the shape of that demand. There's a whole gigantic art and science to that, which EPRI has many capabilities in. And I don't know if you've also heard from anybody on sort of the grid planning side this year. So in general, I'll say until storage becomes cheap and ubiquitous, which it is also, going in that direction, then it's important in general that there's a good match between the available supply and the demand. A lot of the newer nuclear plants have the capability to respond to the load and power down, and can kind of meet more dynamic demand need than some of the older plants can. However, nobody wants to build a plant and not run it all the time, so it's still an economic issue. In some areas, this has been really attractive for the idea of these small modular reactors, because they can be more closely coupled with an appropriately sized load. So if you think about a data center that's going to run 24/7 with very high reliability, a nuclear plant that's matched to that can run, and it won't require a lot of grid support or robustness of the grid to support that. But if you put a very large nuclear plant next to a very small and changing load, that will require a lot of transmission, distribution, and energy management infrastructure to go along with that. We've done some work with some of the newer developing countries. For example, some of our team was just over in Ghana, and they have a desire to add large nuclear plants, but in reality, their grid can really only support smaller, more spread out plants without a major overhaul of their grid, being designed more for a centralized generation and large distribution approach. So I don't know the answers there, but there's a lot to study and examine there, and it does make a difference at the end of the day.
Yeah, Tina. Questions for Tina? Students, please unmute yourself, introduce yourself, and ask the question, please.
Hi, Tina. I'm Ethan Gates. I'm in the IBE program where I'm majoring in electrical engineering. And for the past year, I've been doing a capstone project that's really focused on the grid and long duration energy storage. And one of the main things we focused on is like batteries and behind the meter, actually. And one thing that you mentioned was how solar and wind is actually negatively affecting the economics behind nuclear power. And I was wondering if you could speak a little more to that and how the increased focus on green energy is kind of hurting itself in some ways. That's one thing that we really noticed throughout our research.
Yeah, and I would say that depends on where you draw the box, right? Because overall, having energy available at $0 is good for a lot of people. That example I cited where wind could generate energy and sell it to the grid for $0, and that had a negative impact on nuclear plant economics. I would say overall that probably had a very good, very positive impact if you draw the box differently and say the state of Illinois or consumers in the state of Illinois. And so I think I don't really think like government subsidies are particularly bad or good, but I think it's important to understand that many times the way the economics of a system work drive the decisions that get made in the future. And it's really important for policymakers to set up those economics in a way that will have the outcomes that they intend. I think in this, in the case that I cited, an outcome of increased build of renewables was what was intended, and that was very positive. I think it may have had an unintended consequence of potentially shutting down some very large production of carbon-free electricity that wasn't needed that day, but that will be desperately needed, in 10 years. And if we hadn't shut those plants down, it would have been great. And in fact, there's one plant that shut down, the Palisades plant, shut down due to these economics. And there's an effort underway to now try to bring that plant back online because the situation is changing so rapidly in terms of the value of that carbon-free energy for the future, even though just 2 years ago it wasn't there.
Thank you.
Questions for Tina? Students, please unmute yourself. It's a question. Going once. All right, I want to open it up now to the general audience. Questions for Tina. She brought up a lot of different issues. Questions?
Rudy, this is Hal again. Hal Long.
Yes, go ahead.
A question about if you would tax carbon. I know that's not very positive thoughts about that nowadays, but if you tax carbon, that would make the gas and coal and so forth more expensive, but it would help nuclear because, and it would and wouldn't that be the case? A way to fund the nuclear program indirectly? Yeah,
it really is. And, I think there's many ways that you can account for the externalities, if you will. I think that's how they talk about it in environmental economic space. And if we say that carbon is something we want to reduce, right, or all greenhouse gases, you have like all of these different policy tools. One is you tax that specific thing and you allow the marketplace to find the cheapest way to reduce that specific thing. And that was, I think, in the past, very effective at pollution reduction in many ways. The other ways, though, are like subsidizing the production of cleaner technologies, doing things like loan guarantees or paying for initial pilots to get things over the hump. So there's a lot of tools there. We did some modeling. We do a lot of economic grid modeling. What happens if you pull some of these policy levers? And we were looking at what kind of future economic environment is positive to build new nuclear, what does other things as well, like direct air capture, carbon capture kind of things. And so we just modeled like some different additional revenue to nuclear. So that could come in the form of a credit, a clean energy credit, kind of the opposite of a tax. It could come in the form of selling additional services like grid support, inertia, or even things like hydrogen. And it's really true that for the economics as we understand them today of what it costs for nuclear and what it costs for alternative energy technologies, a very modest amount of credit to nuclear really flips the switch. And I think that's what we're seeing embedded in the thinking and planning for the utilities, for the industrial users, for the data center, the IT community. They are embedding that concept that in the very near future, there will be a monetary value for carbon-free energy, and that is driving them to want to invest in nuclear now.
I want to point out a couple of years ago, one of our capstone students did a kind of a cost comparison of the most popular way then to build power plants, combined cycles, one of the cheapest, with new scale technology, the nuclear SMRs. And it found that they could achieve grid parity if carbon were taxed at $10 a ton. You suddenly see SMRs being very competitive with then the most popular way to build power plants. Things may have changed recently because prices have gone up, but I believe that SMRs can still make the case. But I thought it was a very interesting project my student to find. Questions for Tina?
I see a good question in the chat around China and kind of what's driven their growth of nuclear. So a lot of interesting things going on there. And I would say probably the number one thing that had driven them to nuclear, they had a massive, probably like some of the charts that I showed earlier. In China, they had a massive high rate of industrialization, right? During that period of time where things that we bought started showing up with made in China stickers on them. I mean, that was driven by lots and lots and lots of industrialization in China. It was predominantly powered by coal. And they had huge problems with air quality in China from burning coal. And that, I think, is one of the drivers for them to want to build a nuclear fleet. They wanted to have their mix start to be cleaner from an air pollution perspective. They also are getting massive pressure over the last decades on meeting any kind of carbon reduction, carbon stabilization goals, because there have been a major emitter of carbon. And so, it was that desire they have for large amounts of energy being built very rapidly, and a desire for clean energy, not just carbon free, but also like pollution free energy. And as a government run effort, as opposed to relying on 50 different states and 1,000 or 2,000 different companies to make decisions that culminated in the build of the nuclear fleet in the US. In China, it's a much more run government-funded, state-directed effort to build the plants, and they built up. They had massive infrastructure capabilities already because of their rapid industrial growth that they were able to kind of deploy over to the nuclear build. And they've done a fantastic job of building plants very rapidly with high construction certainty and high cost certainty from their perspective.
We still got some time. Questions for Tina?
If there's no questions, I think I'll end then with kind of the appendix of what about fusion and what about space? And I think that there's been also in these areas tremendous, I want to use the word explosion, but it's never good to use that word in a nuclear discussion. Tremendous growth of activity in both fusion and space. And so maybe I'll just mention fusion first. There are predictions that we'll have electricity coming out of a fusion plant by 2030 to 2035. Not that we'll have commercialized technologies that electric utilities will start to buy because of cost parity to produce fusion, but the advances in the fusion space have been very rapid and rapidly increasing over the last couple of years. Many private companies are getting really close to demonstrating viable fusion designs. It will take many decades or many years to come down to reliable, large-scale commercial deployment. But it's really exciting to watch what's going on in that space. And there's huge potential for that to really introduce a game changer into the energy landscape. And then the other thing that's garnered a lot of attention in the nuclear field over the last year or two is nuclear for space. So there's already some nuclear used in propulsion. There's some nuclear usage in things like rovers, things that we put on other planets or the moon. But in recent years, there's been a reinvigoration of real plans to have presence on the moon and presence on Mars that will require not just propulsion capabilities, but also energy in those places. And there's a lot of work being done, in some cases by the same companies that are working to develop commercial nuclear energy and are working simultaneously with defense for defense energy. There are real activities ramping up now for nuclear as an energy source for our presence on the moon and for our presence on Mars. And those timelines are shorter than what I've talked about for this energy transition. And so that will also create opportunities. It will also create demand and a need to tap into some of these overlapping constrained resources like workforce, like universities, like materials. So it's very interesting.
Yeah, sorry.
All
Questions
right,
for
anything
Tina?
else?
All right.
Quick last question,
Yes.
really quickly. Which country do you think is leading the way in nuclear fusion?
That's tricky. The US is right on the forefront. Canada has some good activity going on, and the UK has some rapid development too. So I think I would say it's a race between US, Canada, and UK.
Thank you.
Oh, thank you, Tina. As you mentioned, although there have been some few setbacks, there's also been a lot of exciting news in the nuclear front. The setbacks in clean energy, New Jersey faced a problem with offshore wind. I think there are going to be some of those, but I think we just need to look at some of the possibilities of success and go forward. Thank you again, Tina. And thank you, audience, for attending and participating in this lecture, and frankly, in the entire series of lectures we had this fall. We're going to start a new series of lectures in the spring. And so please stay tuned because we've got some interesting surprises for you guys. All right. So thank you, Tina. Thank you, everybody. And
Thank you.
See you very soon.
Thank you, Tina.
Thank you.
Nice. Okay. All right, Susan, you there?
I am.
Good. So. Stop recording. Okay.